Hello everyone, in today's presentation I'll be exploring a critical public health question. Do different gender and age groups in New York City experience different death rates from the leading causes? We'll use real-world data and apply statistical techniques to dig into this. We'll explore two key questions. First, are there gender-based differences in how people die? Second, do these causes impact age groups differently? We'll use confidence intervals to estimate average death rates and hypothesis testing to determine whether differences we see are statistically significant. The dataset we're working with comes from the New York Department of Health and Mental Hygiene, spanning the years of 2007 to 2014. Includes key variables such as the cause of death, the number of deaths, death rates, age-adjusted death rates, and information about sex and race and ethnicity. This data is a rich source for understanding the patterns of mortality in New York City, and it provides us with a comprehensive view of public health trends over nearly a decade. To make the analysis meaningful, I grouped the data by gender and three main adult age groups, which covers a large sample size from the population, making the results more robust and generalizable. I also focused only on the top causes of death. This way, we avoid outliers and rare causes and focus on where the biggest differences are happening. For example, we can analyze how males and females differ in terms of mortality rates and explore how these different changes across various age groups. Within this bar graph, you notice that for nearly all leading causes of death, the rates for men are higher than those for women, especially in middle age and older adults, is also known within our pie chart in the previous slide. This presents 95% confidence intervals for the death rates of males and females across the leading causes of death, such as heart diseases, cancer, and stroke. These intervals give us a range of values where the true average death rate is likely to fall. As you can see, the confidence intervals for males and females do not overlap significantly for many causes, suggesting that males experience higher death rates, particularly for diseases like heart disease. This result will be further confirmed through hypothesis testing. We conducted two sample t-tests to determine whether the differences in death rates between males and females for various causes of death were statistically significant. The p-value for heart diseases, cancer, stroke, and chronic lower respiratory diseases are all below the standard alpha level of 0.05, indicating statistically significant differences in death rates between males and females. For example, the p-value for heart disease was 0.03, so we reject the null hypothesis and conclude that male and female death rates for heart disease differ significantly. On the other hand, diabetes did not show a significant difference, p equals 0.23, suggesting similar death rates between genders for this cause. These findings provide strong statistical support for the gender-based disparities in several major causes of death in New York City. Now let's look at how death rates vary by age group. As expected, mortality rates increase with age group, within the 65 age group having the highest death rates for nearly every cause of death. This graph shows the dramatic rise in death rates as individual age, particularly for diseases like heart disease, cancer, and respiratory illnesses. It's clear that age is a significant factor in mortality, and it's important to understand how these trends differ across genders to fully grasp the implications for public health. Also, across multiple causes, we found strong evidence of significant gender differences from our death rates by gender chart. For instance, in the 65 age group, men had significantly higher heart disease death rates than women, with a p-value less than 0.01. Similar differences were seen for stroke and cancer in middle-aged adults. Here, we again use confidence intervals to examine the death rates across age groups. As expected, the 65 age group shows higher death rates, and the confidence intervals for this group are wider, reflecting the higher vulnerability and vulnerability. In contrast, the 25 to 45 group has lower death rates and tighter confidence intervals. These results highlight how age plays a crucial role in mortality rates, with significant differences in death rates between age groups, especially when compared across genders. To summarize the gender-related findings, males have higher death rates across all leading causes of death. We found statistically significant differences for diseases such as heart disease, cancer, and diabetes, where males tend to experience higher mortality. This suggested that public health interventions should focus more on males in certain areas, such as heart disease prevention, which affects them more strongly. Targeted health campaigns for men could help reduce these disparities. Our analysis of age differences reveals that death rates rise significantly as age increases, particularly for 65-plus age group. Additionally, the gender gap in mortality rates becomes even more pronounced in the older age groups, further emphasizing the need for targeted health interventions. Policies and programs aimed at the elderly population should be a top priority, with a focus on reducing mortality from common diseases in this age group. The implication of these findings are clear. Gender-specific health interventions are essential, particularly for males who have higher mortality rates across many leading causes of death. Additionally, given the high death rates in the elderly population, it's important for public health initiatives to focus on disease prevention and early detection, especially in the 65-plus age group. Age-specific healthcare strategies are crucial for improving the overall health outcomes for New York City residents. While this study provides valuable insights, there are some limitations. For instance, the data is aggregated at the population level, which means we don't have detailed individual level information. Additionally, factors like socioeconomic status and environmental influences were not considered. Yet they can significantly affect health outcomes. Finally, these results are specific to New York City and may not apply to other regions with different demographic and healthcare profiles. Future research could build on the study by using individual level data, which would allow for many analysis of factors influencing mortality. Additionally, exploring the impact of socioeconomic status on death rates would provide a better understanding of health disparities. Expanding the study to include other cities or regions could also provide a broader perspective on gender and age differences in mortality.